This is an alternate way to do a question that I've made a previous video of how to find the derivative. So this is just, some people like it one way, some people like it another, so I'm kind of showing you two ways in case one hits home for you more than the other. So here, this problem again is asking us to differentiate, which means take the derivative of this equation here, and then they always throw in this with respect to x, which is just telling us the variable we care about. So looking at this problem, we have f of x equals cosine to the third of e to the 3x squared minus 5x plus 7. Before you go rushing in to take a derivative, you always want to stop and look for a handful of rewrites. One of the rewrites is what we're looking at right now is anytime you've got a trig function raised to a power, you want to do a rewrite on that. Really, when you see something like the sine squared of x, this is better thought of as the sine of x squared. This is sort of shorthand, and this is what you need to do to actually do real math. So rewriting this right now, we get f of x equals, in parentheses now, the cosine of all this stuff minus 5x plus 7, close the top, close the cosine, and then close that whole thing. And we're going to rewrite this all to the third power right now. So the rewrite on this is changing that to all be one huge set of parentheses raised to the third power. As we look at this problem, what we got to say is this is a chain rule inside a chain rule. We see a couple of things that we know are classic chain rule setups. Anytime we've got something raised to a power, that's going to be a chain rule setup. Anytime we see what I call special case derivatives, derivatives that you just have to have memorized, like your trig functions, say cosine or e to the x, those are all telling us that we want to be applying the chain rule. And so to do it in chunks, applying the chain rule, I use the saying d in times d out. So the derivative of the inside piece times the derivative of the outside piece. So we work this a chunk at a time. First, we have inside this third power is going to be this cosine function. So I start right there and I say, okay, the inside on that, looking at that as its own little bite-sized problem, is 3x squared minus 5x plus 7. That's my inside piece, and I would look at that problem now, and I say, all right, well, if I want to take the derivative of that, if I need to find that dn, how do I take the derivative of that? Well, here we can see that we've got a special case of cosine that we would need to take the derivative of. So again, we're looking at another chain rule right now. And so we would go inside that and look at that inside piece. So then that inside piece would be e to the 3x squared minus 5x plus 7. And we would need to find the derivative of that. Well, looking at that, e is also another special case. So we would need to take the derivative of the inside on that piece. So we would need to find the derivative of that in. So that in would look like 3x squared minus 5x plus 7. And to do that dn, we're finally looking at just a straight up power rule. And that's kind of how you know you've reached the end of this little game here, is once you hit that power rule, now the power rule is just our bring the power down, add 1 to the power. So no more chain rule necessary once we're adding and subtracting. So bring the power down and then subtract 1 from the power. So we'll start there and we're just going to work our way back up this thing. It's like a waterfall almost. So the derivative of this piece, bringing our power down, bring that 2 down. 2 times 3 gets us 6x. Subtract 1 from the power gets us x to the first. We've got an unwritten 1 on that x. We bring that down. We get 1 times negative 5 gets us negative 5. Subtracting 1 from the power, x to the 0 power, anything to the 0 power is 1. So 1 times negative 5 just gets us negative 5. And then the derivative of 7, the derivative of a constant, is always the same. So there's our dn right there. Reminding ourselves that in order to do this, we needed to do a chain rule to get to this dn. So that's our dn of our dn, so that's 6x minus 5, but now we also need a d out. Well, the derivative of the outside piece on this, oops, not the d out, just the outside piece here, that is our e to the whatever. So that's e, and then all that stuff we don't really care about. It's just going to be coming along for the ride. So then to find the derivative of the outside right there, that's when we'd have to be looking at our e to the x special case. So that's one of those ones that we just have to have memorized. So if f of x equals e to the x, the derivative of e to the x is e to the x. So our derivative here is just going to stay the exact same. We already took the derivative of that 3x squared piece, and it just comes along for the ride. So 3x squared minus 5x plus 7. So what's really going on here, remember, is that we were in the middle of this chain rule. So to get this d in, we're applying a d in, d out here that we're bringing back up to do this portion. So this d in is going to be 6x minus 5 times, and then your d out, which is e to the 3x squared minus 5x plus 7. So that's our d in for this first tier here, for this piece here, this chain rule. But that also means we still need a d out for that. So the outside piece here is going to be this cosine function. It's going to be the cosine of all that junk. And again, we don't care. It's just going to be coming along for the ride. And so the d out on this is another special case. The derivative of cosine is one we just have to know, have to have it memorized. The derivative of cosine is negative sine. So our derivative here, our d out right here is going to be, the derivative of cosine is negative sine, and then we leave alone all the junk that we already took the derivative of, this e to the 3x squared minus 5x plus 7. So then the weird thing here is that this all really began because this was our original in from our original chain rule recipe. So really right now, we have our d in, d out that we're going to need to put together our full d in up above here. So then that's going to get us, for the d in on that, we are going to be looking at d in, d out. So that's going to be, this is our final derivative here. So this is our actual f prime of x. So the derivative of this inside piece is d in 6x minus 5 e to the 3x squared minus 5x plus 7. D out, remember to put a parenthesis whenever you got that negative sign, or else they will happily read it as a subtraction. So this is our d out. And then all of that is times our overall d out, which is this third power from way back at the beginning. So this is going to be a power rule. Bring that 3 down in front, leave alone all the junk we already took the derivative of, and then subtracting 1 from the power would get us to the squared. So then inside here would still be the cosine of e to the 3x squared minus 5x plus 7, close, close. So what you're looking at now, and this was just, working your way back through the layers, this is the d in from our original function. That's the derivative of all that stuff inside there. And then this is our d out. That big power rule right there. But inside that was about a few more layers of doing the chain rule. So again, some people can see it really well this way. Other people, I like the other way that I do in the first video, which is the inside out method. Take a look at that as well. But leave your answer right there. You're done. Walk away. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.